So what was your question today, Artis?
How do these two work?
Okay, so this is called the spark plug. This is called the ignition coil, okay? Engine takes air and fuel, compresses it. Something needs to ignite it. So we use arc to ignite the air-fuel mixture, which then creates that bang that makes the piston comes down and creates power, turning gas into kinetic energy, okay? Now, how do we get spark? What we use is the ignition coil. This thing takes 12 volts, turns it into thousands of volts, enough where there is an arc or spark between that gap. And that spark then ignites the air-fuel mixture, okay? How does a step-up transformer work? It uses the relationship between magnetic field and electricity. It has two coils inside an ignition coil. One of the coils is called the primary coil, and the other coil is called the secondary coil. So just imagine a piece of wire coming out and then turning into a spiral coil, and then imagine another one coming out and having many more windings. You put 12 volts in here, you get a magnetic field around these windings that cross over the secondary coil. This is your primary, which has less coils. It's for your low voltage. This is what creates the high volt coming out of here, called the secondary ignition coil. If you get power and ground here, you'll get a magnetic field going around the primary coil, which will then cross, the magnetic field will cross over the secondary coil, but since there are many more of those, when you turn the power off, that magnetic field collapses, causing a voltage spike in this coil. And that voltage spike is what comes out of the ignition coil and jumps across the spark plug gap.
Okay.
Igniting the air-fuel mixture. Not difficult, right? Now, can you explain it to me?
Okay.
Alright, so you got that?
Yeah.
Does it make sense? Now forget the camera. Now for you to understand it, okay?
Okay, fine. Go.
Okay? This is the ignition coil. Again, it does take 12 volts. It does turn it into thousands of volts.
Okay.
And it does that by, again, it has a primary coil inside and secondary coil inside. It's like a spring, okay? Yeah, these things that I do. It's like a spring. You know what a spring looks like, right?
Yeah, right.
So there's two springs. One spring that has, let's say, 10 coils, and then another one that has 50 coils. Okay? You put 12 volts in the primary coil, let's just call them spring, correct, the 10 coil ones. When you give it power and ground, it has a magnetic field around it, okay? Anytime you have electricity flowing, you have magnetic field, okay? So you have magnetic field, and those windings, the magnetic field then crosses over the secondary coil, okay? The windings of the secondary coil, which has 50 exactly. And when that magnetic field collapses, it creates voltage inside the secondary coil.
Is that what ignites?
That's what creates thousands of volts that is able to jump a gap.
Oh.
You know, like a Tesla coil, like such a high voltage potential that it can actually jump across air.
So
the electron.
So this is connecting the voltage is going up
to the center of it.
And after that, it's just doing a low. Then the electron's doing a low jump up here, which is then igniting the thing. Okay.
Correct. Yeah, it's the electron that's jumping. It's probably not one electron, right? It's thousands of electrons or whatever, right?
Yeah.
Because there's a duration of it, right? The bigger the gap, the higher the voltage will build up in that coil. So if this gap, if I open that up higher, this coil will produce even more voltage. But then the duration will be smaller of the spark. Okay? If I close this gap, it will actually produce low voltage, but the spark will last longer period of time.
So lower voltage, but then the charging would then be like lasting longer, right?
Lower voltage, but it will last longer, correct?
And then if this is higher up, then more voltage will be compact. Then after that, it will be able to reach like where the second one is, right?
What the second one? You say higher voltage will go across and jump across that gap, right?
Yeah. So like
Okay.
it would be able to reach the gap then.
Yeah, it will jump. The electrons will jump the gap,
Okay.
igniting the air-fuel mixture, right? But then I was going more into detail
Right.
of what is the purpose of the gap, how much should the gap be, and of course the manufacturers give you all the specifications, but there's a reason why there's different gaps, right?
Okay.
Sometimes if the engine is designed to need higher voltage to jump this gap, they would open this up further.
Okay.
If they want the gap to last or the spark to last longer, they will have a shorter gap, and all of that is engineered. So that's why it's important to make sure that the gap is correct when you replace the spark plug. Most of the spark plug nowadays come pre-gapped.
Yeah.
But it doesn't hurt to check the gap before you install it in the car. What I normally do is if I get 4 spark plugs on a 4-cylinder car, I will actually take all 4 of them out of the box. I'll set them down. I'll look at all of them to make sure they're all same. Okay? You can go one step forward and actually look up the spec and just check one of them and make sure they all look good. Because nowadays you do have like iridium tips, platinum tips. So they're very, very, very thin and sensitive tips, so you kind of don't want to pry anything against this, so you want to be careful. But yeah, that gap is important, okay? Making sure there's no cracks in the porcelain is important. How do you know a spark plug's gone bad and needs to be replaced? If you look at a brand new spark plug, you see nice, pointy, you see how there's a point there's a point there. What I mean by point is an angle, right? Whatever that is, 30 degree, 40 degree, 80
flat,
degree.
then it's bad then?
If it's round, is bad.
Okay.
Spark likes to jump off of 90 degree angles. Well,
Right.
maybe that's not, it likes to jump off of a point. Okay, spark likes to jump off of a point. So as spark jumps off of a point from here to here, is gonna eat away some of the sharp edges.
Okay.
Because it's spark, right? So it's gonna eat away some of the sharp edges. So if you take a spark plug out and you see the center part is all rounded, the center electrode, the outer electrode is all rounded, that spark plug is bad. Okay. Sometimes mechanic will say, oh, this gap is too big, that's why it's bad. No, you can re-gap a spark plug. I've also heard mechanics say spark plugs never really go bad, you just need to clean them and re-gap them.
No.
They're missing the part that spark likes to jump off of 90 degree angles or sharp points. And once those sharp points are gone, it takes more effort to jump that spark, okay? And it's more wild, it's not as controlled, and the gap is not controlled, because sometimes it'll jump this way, sometimes it'll jump that way. So could you take a file or sandpaper and turn them back into 90 degrees? You potentially can, but in my opinion, spark plugs aren't that expensive, so just get a new one and replace them, right? And then nowadays they make spark plugs with, like I said, platinum, iridium. They last 100,000 miles, so you're not changing them that often anyways. But spark plugs do go bad because they wear out. And then ignition coils. Ignition coils fail too, okay? How do you test the ignition coil?
Open it up.
Nope. How do you test the ignition coil?
Oh, test it.
You leave it connected.
Yeah.
You pull it off the spark plug, and you hear for a spark.
And if there isn't a spark, then
there's a spark. Now there's a tool that we can put in between here and here that will actually show us the spark in a form of a light. There's also a tool that I can connect here and ground the other end of it and actually show me a spark, and I can adjust it to see how much spark I can get out of it. I can also use a scope to do all of it. But in all reality, in the shop, out in the wild, when you're working and this cylinder is not firing and not working, I'm gonna go in there, I'm gonna pull this up, and if I hear tick, 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 I just tested the coil is working. Well, the coil at least is creating spark. I just made sure that my primary circuit is good. Because if this wasn't there, it wouldn't spark at all.
Right.
So I just tested those two things. Now at that point, once I pull it off, you can still have a boot that has a leakage, like it's arcing to the side. Okay. So you can test for that. You can see marks, burnt marks, spark marks. You can also, when you pull it up, look down the hole where the spark plug is. And if you see a spark going sideways outside of this point, you know that this boot is leaking at this point. It's got a pinhole somewhere.
Right.
If you pull it up and you don't hear any spark,
That's bad.
don't be that quick to judge. We didn't check the primary circuit, right? So then you pull the primary circuit out, you stick a Noid light in it, which is a fancier way for an LED bulb.
Okay.
If you have a power probe, you have a test light of some kind, you want to make sure you got constant power on one of the wire, which is going to be 12 to 14 volts, depending on the battery voltage at that time. Car is running, obviously. So the alternator charging is probably closer to 13 and a half, 14. You're going to make sure you have battery voltage over there at that time. And then the ground wire will be going on and off.
Okay.
When you're testing that, to see it's pulsating, right? Because again, you're making the magnetic field, you're collapsing it, making the magnetic field, collapsing it, right? So that power is going on and off in the primary circuit. You want to test for that pulsation.
Okay.
When you're testing for that pulsation, you also have to be careful not to load that circuit with too high of a load. Okay, what that means, don't hook up a very, very strong bulb or something like that, because that can damage the driver. Because who's giving the pulsation here? You know, the on and off?
Yeah.
The computers, the ECM, engine control module. PCM, powertrain control module, right? The modules I told you, there's a bunch of onboard computers in the car, right?
Right.
So the computer that controls all the engine functions
It's also controlling these.
is also turning this on and off.
Okay.
Because it is very important for this spark to happen at the perfect timing. Meaning when the piston comes up, it is mixed air-fuel mixture, everything is compressed, that's when it wants to ignite, right? It actually ignites it before that, because it takes time for that flame front, as it ignites it, for that flame to come down. It takes time, and the pistons are moving so fast, it actually ignites it before it can reach top dead center. That's another word, top dead center. We'll talk about that later, okay? That means pistons all the way up on a compression stroke, okay? So it comes up on a compression stroke, spark will ignite, and that will bring the piston down, and yeah, so it's important for it to be on time. Computer, ECM, PCM, module, whatever you're gonna call it, bunch of words for the same thing, controls the spark, the coil, and the timing of it all. And of course, it uses many, many sensors to be able to control that on time and all of that, okay? All right, correct.